Hi everyone, this video is going to go over the concepts of sequences and series. So the first thing we need to remind ourselves is there are two types of sequences and series, arithmetic and geometric. Arithmetic have an adding pattern, adding or subtracting, and geometric have a multiplying pattern. The arithmetic have an adding or subtracting pattern, and the number that you use to get from term to term is actually called the common difference. They maintain a constant rate of change, and they can be modeled by a linear function. So when you think about a line has the constant slope, y equals mx plus b, where m is the slope. And basically it's that same rise over run, rise over run, rise over run, constant rate of change. That is what classifies a linear function. So similarly here, to get from term to term, we want to get a common difference of 4. So basically that would be equivalent to the slope on the line being 4 over 1. So can we keep adding 4, adding 4, adding 4 to get to the next term? All right, so notice arithmetic, you think AA, arithmetic add. And are we adding in this first one? We are not. Second one, we are not. The third and fourth one we are adding. And which one has a common difference of 4? The answer is choice 3. I'm hoping you'll say, because to get from term to term, we would have to do plus 4, plus 4, plus 4. Now to get the common difference, what you can do is, this is called lowercase d, the common difference by the way, is you can do this any term minus the previous term. So for example, if I take this second term here, n plus 5, and I take away the one before it, n plus 1, I should get 4. And I will, because the n's will cancel out, and I am going to get positive 4. So indeed, the answer is choice 3. Now, arithmetic is less common on our regions because arithmetic was from Algebra 1. So keep in mind, you're not really going to see arithmetic. You're actually going to see more geometric. Now, if you wanted to do an explicit formula for arithmetic, you would go to the reference sheet and you would look for this formula. And I'm just going to tell you what it means. A1 means the first term. The n means any term, the term number that you're interested in, basically. And then the common difference is the letter D. That's here. I'm going to skip this recursive part and go on to geometric. Now we go to geometric. Geometric sequences have a multiplying pattern for dividing, because multiplying and dividing are inverses, right? They have what we call a common ratio between the terms, and that's denoted by the letter lowercase r. They have a constant percent rate of change, not a constant rate of change, and they model an exponential function. This is more common in Algebra 2. This is where we really jive here in Algebra 2. Exponentials, functions, and geometric sequences. So if we were to look at the reference sheet to get the explicit formula for any term, for a geometric, you would look up this formula here. A sub n equals a1 times r to the n minus 1, where a1 is the first term, n is any term or the term number that you're interested in. Like the fifth term, we would plug in 5 there, for example. And then the r is the common ratio. Now notice the r is a base, and the base has to do with the base of an exponential function. So keep that in mind, that remember in our last video we talked about 1 plus the rate or 1 minus the rate. If it is increasing by a percent rate, it's going to be 1 plus a number, and then the number is going to be greater than 1. And if it's decaying or decreasing, it's going to be 1 minus the number. All right, so now here's some examples. So the first one says, consider the following patterns. Which of the following is geometric? So we're looking for a multiplying pattern. So I want you to think GM, geometric multiply. So check it out and see if there is one that has a constant ratio, a common ratio. Now the way that you can find the common ratio r is you can just take any term and divide by the previous term. And when you do that, you should obtain the common ratio. So take a minute here to look at it and see if you can figure out which one it is. So I actually just worked out that first Roman numeral 1, and I saw that if I took the second term, which is negative 12, and I divide by the previous term, which is 16, I'm going to get the same common ratio that I would get if I took the third term, 9, and divided by negative 12. So if you do any term divided by the previous term in that row 1, you're going to get negative 0.75, which is indeed the common ratio. So notice that the numbers are going down, which means decay. You're actually multiplying by a common ratio of negative 0.75. So the answer is choice 1. So my best advice to you is take any term, divide by the one before it, then take another term, divide the one before it, take another term, and see which one gives you a common ratio. If you were to go to Roman numeral 2 and take the second term 4 and divide it by 1, you'll get 4. But if you take the third term 9 and divide it by 4, you won't get 4. So that's why that ratio is not in common. Now, sequences can be written as explicit or recursive formulas. Explicit is what I just showed you on the previous page. They're the ones that are written on the reference sheet. And basically explicit is nice because you can plug in any term, like the 100th term, plug it in for n, and you will get the 100th term. However, with recursive, it's a little bit more tedious because you need the previous term to get to the next term. So the prefix re means go back. And that means go back, rewind, reflect, repeat, review. So repeat, I said that already. Get it? Repeat. Anyway, so we're going to use the previous term to get to the next term. And the reason why that's annoying is because if I'm looking at the 100th term, I need a 99th term to get to the 100th term. So I'd have to really write out all 99 terms to get the 100th term, which is a pain in the butt. So the main thing that you need to know is recursive formulas have two pieces. And the two pieces consist of, one, the initial term, which is the starting term, A1. And then they also have a formula that involves something involving the previous term. So if I'm at the term an, the one before me is called a sub n minus 1. So that's what this is saying here. So this is the multiple choice question over here from the Regents. It's very common. They'll ask you which of the following is a recursive formula. So the first thing to note is we can eliminate choices that don't have two pieces because we need two pieces for the recursive formula. So choice 1 is out. And if you look, you can see choice 3 is out. So now we're down to 2 and 4. And if you know that we're in Algebra 2, you probably know that it can't be choice 2 because choice 2 is subtraction, and subtraction is arithmetic. So it's probably going to be choice 4. So let's see if we can figure out the pattern from term to term. See if you can figure it out. What is the pattern happening from term to term? And remember, if you want to find the common ratio, you take any term and divide by the one before it. So 30 divided by 40 is 0.75. 22.5 divided by the one before it, 30, is 0.75. So it looks like the common ratio is 0.75, which is 3 over 4. And this is decaying or decreasing. So that's why we're actually maintaining 75% and 25% is decaying. So the answer is choice 4. Now, we can also go to the second example here because this one is a free response. So this one is giving you the equation set up as a recursive. So there are the two pieces. The first term here is 3. And then they're saying use this formula here to find the first 4 terms. So I'm guessing we're going to use A1 to find A2, A3, and A4. So A2 is going to be the next term. And this formula basically says this. It says take the previous term, which is A sub n minus 1, multiply it by 2, and then add 1. So I'm going to write that in English. 1 plus 2 times the previous term. 1 plus 2 times the previous term. 1 plus 2 times the previous term. I'm going to write that for A3 as well. 1 plus 2 times the previous term. And for 4, 1 plus 2 times the previous term. Once I set up that shell, which is basically like the formula that I'm plugging into, now I'm just going to drag and drop the last thing into that spot. So the previous term was 3. So I'm going to do 1 plus 2 times 3. And then whatever you get, you're going to put in the next slot. And then whatever you get, you're going to put in the next slot. So do it now. Let's see what you get. So check your work and see if you got this right. I'm hoping that you got for A2, the second term 7, the third term 15, and the fourth term 31. So if we had written these all out in a line, we would have A1, A2, A3, A4, and we would have the pattern 3, 7, 15, and 31. So the question says, can the sequence be represented as can be represented as an explicit geometric formula? So is there a common ratio from 3 to 7? Is there something that you can multiply by to get to the next term consistently? And I want to show you that if you took the second term 7 and divided it by 3, you would not get the same as 15 divided by 7 or 31 divided by 15, because this formula consists of both addition and multiplication. So we cannot use a geometric formula alone for this. So we want to say, no, this is not a geometric pattern. So we can't do the formula for that. Now I want to bounce back to the two things that I skipped, because now you know recursive has two pieces. You can go back to where it says arithmetic. The general recursive formula for an arithmetic sequence would be, the two pieces would be A1 equals whatever, and then AN equals A sub previous term, AN minus 1, and then plus whatever the common difference is. Whatever, or minus, right? Whatever the common difference is. So basically the first term would be A1, and then the previous term would be the A sub n minus 1, and you would add the common difference or subtract it. I guess if it's a negative, it becomes addition anyway. So similarly with geometric recursive, two pieces. The first part is the first term is A1, and then A sub n is going to be dictated by the previous term, A sub n minus 1, and then times the common ratio r. Okay, or division, right? Because it could be a fraction. So there you go. Now let's wrap it up with series. So series is just the sum of the sequence. So the sequence is the list of the terms that have a pattern, and then the series is we're going to add them all up and just get the sum or the total. So look for keywords that say total or sum, and that's going to tell you that you're doing the series formula, not the sequence. So you're going to look on the reference sheet, and on the bottom right there is this geometric series formula, and it's right here. And notice there's that capital S. Capital S stands for the sum, and S sub n means the sum of n terms. So that means the n is the total number of terms that we are adding up. The A1 is the same, that's the first term, and the R is the same, the common ratio. Remember, the common ratio is made up of 1 plus the rate or 1 minus the rate. Okay, so be careful with the R's. Now, sums can be written in the form of either this formula here, or they can be written in what we call sigma notation. Sigma is this Greek symbol, which means sum or summation. And that means basically add all the terms up, which is what we said. And basically, whenever you're doing that sigma notation, you start at your starting term down here. It could either be 1 or 0. Usually, it depends on the situation. And then this will be your ending term here. That's like the upper boundary. And then what goes over here is going to be the explicit formula for the geometric sequence. Right? So there's two ways to represent the same thing. Now let's look at some examples. So look underneath, and let's look at this first term here. So take a look at it, read it, and see if you could set it up. All right, so let me explain some of my work that I have here. The first thing I did was determine the common ratio by dividing every term by the previous term. And I saw that there was a multiplying pattern by -3. So I know that this is a geometric which they're really going to be geometric on your regions. It's a geometric sequence, and the common ratio is -3. It said there were 20 total terms, so that's going to be n, and the first term is a1, which is -2. So now I'm going to go get my formula for s sub n, and I'm going to plug in everything I know. So s sub n equals a1 minus a1 times r to the n over 1 minus r. So let's plug in. After you plug in, you're really just going to put this right in the calculator. So do that now. So hopefully you have the setup correct in your calculator. Be careful with all these negatives and which ones are being parenthesized. Only the -3 is being raised to the 20th power. And who got this crazy big answer? This is actually choice 3. Good job if you did. Now let's look at the one underneath here on the left column. The initial push of a child on a swing causes the swing to travel a total of 6 feet. Each successive swing travels 80% of the previous swing. Determine the total distance to the nearest hundredth of the first 5 swings. So first I want you to see if you can write down some key information. So I'm hoping you realize that the first term, the initial term or starting term was a1 was 6. The common ratio is 0.80. And then it looks like we're doing 5 total swings. So that's going to be the sample size of 5. So now you're going to plug in and solve. All right, so I set up the setup and I plugged in and it says nearest hundredth. So I'm hoping you got 20.17 for your answer. Now let's look on the right hand side. On the right hand side of this column we have another one. Let's read it, underline, and see what you can do. Go. All right, so this one, you may not have realized that it says an increase of 10% per week, an increase of 10% per week. So the reason why that's important is because when you do the common ratio, you have to do 1 plus the rate as a decimal, which is going to be 1 plus 0.1 or 1.10, because you want her to increase over time. So notice we can already eliminate choice 4 because that has the wrong R here. That's out. The first week she had 8, that's A1, and then there's a total of 6 weeks. So let's first start with this S sub n formula and see if we get the answer. S sub n would be S sub 6, 8 minus 8, common ratio 1.10 to the n, 6 over 1 minus r, which is 1 minus 1.10. I'm hoping that you're realizing that that is actually not choice 3 because choice 3's denominator is 0.90, which is not 1 minus 1.10. So it's not going to be the S sub n formula. In fact, it's going to be one of these sigma notations. So take a look and see if you could decide between the two, A or B, 1 or 2. So the main thing you need to know is that the formula that goes to the right of the sigma is going to be the explicit geometric formula. The explicit geometric formula is an equals a1 times r to the n minus 1. So the answer was actually choice 1 because there's an n minus 1 here. And that is important because when you plug in 1, you want to obtain week 1, which is 8. So if you plug in 1 in here, you're going to get 1 minus 1, which is 0. Anything to the 0 is 1, so you will get 8 for week 1 versus this one, you will not. All right, so that's that. Now I want you guys to try some of these examples down below. Good luck.